Okay, now given the equation of a hyperbola in standard form, we want to locate its vertices and foci. Number one, we want to determine whether the transverse axis lies on the x or the y-axis. And notice that a squared is always under the variable with the positive coefficient. So if you let the other variable equal to 0, you can easily find the intercepts. In the case where the hyperbola is centered at the origin, the intercepts coincides with the vertices. Now, if the equation has the form x squared over a squared minus y squared over b squared is equal to 1, then the transverse axis lies on the x-axis. And the vertices are located at plus or minus a, 0, and the foci are located at plus or minus c, 0. If the equation has the form y squared over a squared minus x squared over b squared is equal to 1, then the transverse axis lies on the y-axis. The vertices are located at 0 plus or minus a, and the foci are located at 0 plus or minus c. In step 2, we're going to solve for a using the equation a, which is equal to the square root of a squared. We're going to solve for c using the equation c, which is equal to the square root of a squared plus b squared. Now, locating a hyperbola's vertices and foci. Identify the vertices and foci of the hyperbola with the equation y squared over 49 minus x squared over 32 equals 1. So, the first thing we want to do is we want to look at which term is negative and which term is positive. Well, the y squared over 49 is a positive term. So the equation has that form, y squared over a squared minus x squared over b squared is equal to 1. So the transverse axis lies on the y-axis. So the hyperbola is centered at the origin, so the vertices serve as the y-intercepts of the graph. To find the vertices, set x equal to 0 and solve for y. So we can go ahead and do that if we want to. I'll show you two other ways, but if we let x equal 0, we get y squared over 49 minus 0 squared over 32, which is equal to 1. So that becomes y squared over 49 equals 1, which becomes y squared is equal to 49, and y is going to equal plus or minus the square root of 49 equals plus or minus 7. Or you could automatically determine that the value of a squared is 49. So if we take the square root of both sides, we have a, which is equal to plus or minus 7. So therefore, we have 0, negative 7, and 0, 7. We can also find out what are the conjugate vertices by looking at b squared and setting that equal to 32. Well, b is going to equal plus or minus the square root of 32, and therefore b is going to equal plus or minus 4 times the square root of 2. So we have negative 4 times the square root of 2, 0, and 4 times the square root of 2, 0. So now we know what those are. So we can either do this, or we can go ahead and find the vertices and conjugate vertices by just using what we did in our previous section with the ellipse. Now the foci are located at 0 plus or minus c. In solving for c, we know that c is going to equal the square root of a squared plus b squared, which is equal to the square root of 49 plus 32, and that's equal to the square root of 81, which is equal to plus or minus 9. So therefore, the vertices are located at 0 plus or minus 7, and the foci are located at 0 plus or minus 9.